Before we move on to doing any data analysis, we usually need to check if there is any missing value in our data. That is, the source may have failed to collect all the information. We can first use the info function, which will return the total number of observations that have real values for each variable. By comparing these numbers of observations across the variables, we can see if there is any variable with missing value. As we can see from the output, most variables have 18,421 observations, but some variables, for example, WL, FG underscore PCT, have less than 18,421 observations. This means that some observations are having missing information on some variables. We can also use the is no and not no function in Python to detect observations with missing value. There are two main approaches to handle missing values. So first, we can simply drop the observations with missing values. We can use the not no function from Pandas library to drop observations with missing value in certain variables. For example, if we want to drop observations with missing value in the field goal percentage, which is FG underscore PCT, we can use not no function to keep all the observations that do not have missing value in the FG PCT variable. Notice again, we are essentially creating a new data frame with no missing value in the specified variable and replace the old data frame with the new one. Another approach is imputation. So rather than dropping all the observations with missing value, we may want to replace the missing value with valid values instead. We can use the fillNA function to replace missing values with other values. For example, if we want to replace the missing values with the mean of that variable, we can use the fillNA function, and inside parentheses, we can specify the replacement to be the mean of the variable. It is important to note that data imputation may have different consequences depending on the proportion of missing values and the nature of missing values. So whether it is missing completely at random or missing at random or missing not at random. For example, if all the observations with small values are missing from the dataset, then the median of the sample would be larger than what it actually should be, and replacing the missing value with the median would not be the best approach. In addition to dropping variables, we could also create variables. We can simply use the equal sign to create new variables. For example, we can create a variable that equals to the total number of goals made by For example, we can create a variable that equals the total number of goals made by adding the field goal made, 3-point field goal made, and free throw made all together. More often, we may want to create a variable based on some conditions. That is, we can create a new variable conditional on the value of an existing variable. For example, we can create a variable result that equals to win if the team won the game and lost otherwise. The result of the game can be captured in the final scores of the game. In our NBA games data frame, the variable plus underscore minus indicates whether the team got a positive or negative score in the end. So we can use the where function from NumPy library to define this new variable result. In this line of code, we create a result variable based on the value of a plus underscore minus. If plus minus is less than 0, if plus minus is greater than 0, then we assign a value w to the result variable. If plus minus is less than 0, then we assign L, then we assign a value of L to the result variable. Since we already have a WL variable to indicate the result of the game, we can drop our newly created result variable. We can also create variables within groups. In the dataset, each game has two observations. One represents the statistics of the home team. One represents those of the away team. Both observations have the same game ID. We can create a variable points difference that equals to the difference between the points earned by the two teams. We first need to sort the data not only by the game ID, but also by the result WL variable. This will move the two observations of the same game adjacent to each other and put the winning team above the losing team. Now we can use the group by function to create a variable point underscore diff that equals to the difference in the point variable PTS between the two teams in the same match. And this is identified by the game ID variable. The point diff variable only has the point difference for the winning team, but not the losing team. So we actually have a missing value problem here. We could use the fillNA function we just learned to replace the missing value with the valid value. In this case, we want to fill the missing value based on the group game ID. Since now within each group, there's only one observation with real value, we can simply fill the missing value with the mean of the observation. Notice that inside the fill function, we first group the data by game ID and then take the mean of the point diff variable for each game ID. We also need to use the transform function to make sure to map the group-wise mean to the index of the original data frame. As a final step, we want to make sure that there's no missing value in our data frame. We can drop observations with missing value using the drop NA function. In practice, if one variable has a large proportion of missing value, it may be better off to drop the variable instead. Otherwise, we may have to lose a large number of observations. Sometimes we may want to work with season level data rather than team level data. We can create a new data frame that includes aggregate information of team statistics in each season. We'll continue to use a group by function and specify the criteria for the group to be team ID and season ID. If you want to look at the sum of the team statistics, we can first select all the variables that we want to include in this season level data frame, and then use the sum function in the end. Notice that in this newly created data frame, there are two levels of index, team ID and season ID. If we want to convert these two indices back as variables, we can use the reset index function. We may be interested in knowing how many games a team played in a season. We can also create a data frame that equals to the total number of observations within the same team ID and season ID using the size function. We can use the reset index function in the same line of code, and inside the reset index function, we can also name the newly created variable to be game count. To save datasets after we perform data cleaning in Python, it may be useful to export the data frame back to a CSV file. We can use the toCSV function to save the merged data frame as a CSV file. We'll specify index equals to false so that there will not be an index number added to the CSV file for each observation. A new CSV file containing the dataset will be created in the same folder where you have your Jupyter notebook.